Okay, decomposition is the next type of reaction we're going to practice. So decomposition is the opposite of synthesis. Instead of coming together, something is decomposing, it's falling apart. So you're going to have, think always, just one compound. There's just one compound and it falls apart into elements, or into an element and a compound, it falls apart into more pieces. So the thing you're going to look for is if there's only one reactant. If there's one reactant, there's nothing else it can do other than fall apart, decompose. In order to be able to solve these, there's a few things you need to know. For one, you have to know your polyatomic ions, because again, these are given to you as word equations, and if you don't know what the formula is, you can't write the equation. Also, you're going to want to know common gases that form. Like if you heat carbon dioxide, it gives off if you heat carbonate, it gives off carbon dioxide. If you heat sulfate, it'll give off sulfur trioxide. If you heat sulfite, it'll give off sulfur dioxide. And if you heat ammonium, it'll give up ammonia. So make sure you do those. And also when you're decomposing, don't forget the Hofkrinkel again. So, all right. Oh, and another one is you're usually heating these things and you're heating them in a vacuum. If you weren't in a vacuum, that single reactant that you know of could react with air, any component of air. So if we're heating in a vacuum, that's going to be, you know, a good indicator that, like, let's see, well, we only have vacuum ones, but and none of these are going to say are heated in air, so we don't have to worry about the air, but that's how we know. So, okay, so I've got powdered magnesium carbonate. So magnesium is Mg with a 2+, carbonate is CO3, has a 2- charge, so those charges are balanced out. I only have one reactant, the only thing it can do is decompose. So I'm going to make this thing fall apart. I know when I heat carbonate, I can give off carbon dioxide, so CO2. And what I'd be leaving behind if I take CO2 from here is an Mg and an O. So magnesium oxide, and that is the other product. And this reaction is already balanced. So next I have solid calcium sulfite. So I know calcium, Ca with a 2+, sulfite is SO3, it has a 2- charge, so those charges are balanced. And I know when I heat this thing that I give off SO2 as a gas, sulfur dioxide. And what I'm leaving behind is calcium and 1 oxygen, so CaO. The next one I have calcium carbonate. Very similar. Ca with a 2+, carbonate, CO3 with a 2-. So you probably know the gas that you can make when you heat carbonate. Carbon dioxide. And if I took carbon dioxide out of this compound, you can see what I'd be left with. Calcium oxide. And that's it. Then the last one we have solid ammonium carbonate. So ammonium is NH4. It has a 1+ charge. Carbonate has a 2- charge, so I'm going to need 2 ammoniums and 1 carbonate. Okay, so I can see 2 things that I heat and I give off gases. So when I heat carbonate, I know I can produce carbon dioxide. And I know when I heat ammonium, I can make ammonia. So there's going to be 2 ammonias, 2 NH3, because I'm heating those guys. And then you can see what you're left over with. When I took the carbon dioxide out of this, out of the CO3, I'm leaving 1 oxygen behind. And for each ammonium that I turned into ammonia, I left a hydrogen behind. So actually an O2- and 2 H+. So I can see that I'm making H2O. Okay. One of the tricks with all of these in the AP, like the purpose of these is to see if you did any labs and if you recognize common reactions that occur. So look for common products that you know. Like you know water, H2O.